G'day world, Chris Hogan coming to you live from Chancellor State College, and we're investigating some robotics here. What have we got here, Simon?
That's right, this is a First Tech Challenge robot that the Robo Kings built last year and through the Christmas holidays, and we took it off to Houston and competed against the world's best teams, Google, NASA themselves, Tesla, and Chancellor State College from Australia. They couldn't believe that, that we were producing something of this size and speed.
That's so cool.
What the boys managed to build was actually the fastest robot in the world for 2018, right here on site, using their own skills. Essentially, it's a base kit that everyone gets everywhere around the world at the same time, but you can add to it, you can add any parts you like. We can 3D print parts, we're cutting and bending acrylic, and we're cutting tin and using our CNC machine just to bring up the level of the robot. You saw earlier that a pushbot is a basic build, and a lot of schools and teams just sort of stay at that level and have a go. This year we had to pick up foam cubes like this that were scattered around on the floor, 2 different colours, plus red and blue balls were scattered around on the floor, and there was a balance table like a seesaw bridge that you had to get on and off. So the boys had to work out how to get these blocks on board as fast as possible. That's one job in itself, but there are about 4 other things that they had to conquer in this coding competition. At the very start, the robot needs to use a gyro sensor to come up and balance on a board, and then it needs to seek around in the room. It runs off a mobile phone app.
Of course it does.
So what you saw earlier is that the boys are using the apps. They're writing JavaScript code onto there that Bluetooth connects to the robot, and they plug in handheld consoles. But there's an autonomous stage for 30 seconds where this robot has to do everything itself. So it uses the camera on the phone to look for posters on the wall, and it decodes those posters which tell it where and how it's got to stack these blocks. It takes itself off that seesaw bridge using the gyro sensor, and then I said there are red and blue balls that are around on the floor, so it needs to determine what color they are. So it drops an arm down with a color sensor on it, and if it's red it knocks them one way, and blue it knocks them the other way. So it sorts colored balls like that. And then of course it's got to go and pick up the bricks, and you can probably see from this system that the boys have made 6 intake wheels that come onto this tray. They're only allowed to transport 2 at a time, and the idea is that you stack these up in a pattern into a box that I've got behind here. So they've got 12 to stack as quick as possible. Now there are 2 different coloured bricks. They're actually brown and grey ones, and you get more points for doing different patterns. But you don't know which pattern you're meant to be stacking until you've read that poster with the visual cue and prompt. So they stack them, they worked out, they've been through about 6 different iterations of this robot. This is the culminating robot, but they've been through a lot of very complicated design thinking process to get to this point. You're probably wondering, what do they do with these 2 on board? They've made it so that it actually flips them straight out the back, and which means they can put them straight into the rack as quick as possible, and the whole lot goes up to height, so they can put 2 on top of 2 and make a stack of 4. And they're just small things, but this robot doesn't turn round. They worked out they're saving 30 seconds out of 2 minutes. Not only can this complete the task, but it also, we work in pairs with another team, and if their robot broke down, we can actually complete their task for them as well. To be able to get into the top 10 in the world, you need to make sure you do your job, but you cover your teammates' backs when their robot breaks down as well. We've had to do that a few times.
Very cool.
At the end of this, a little action figure needs to be rescued. So they've got an arm that comes out and a grabber which grabs him by the head and picks him up to safety and puts him out over a 2-meter barrier at the end. And that's still not quite finished. That robot needs to get back up onto that seesaw bridge at the end of the game. So there's a lot going on with our robots.
Yeah. And you said they were competing against teams from NASA and all different organisations like
That's
that.
right.
Yeah.
We've managed to really bring up our status in world robotics to the point where we're on good first name terms with the NASA engineers. We're using Skype this season to check that our drivetrain systems and our coding is up to scratch. They've been really helpful. That
That's really
they
cool.
can see that
And the
these.
students get access to those experts.
That's right. Regular Skype calls with NASA is what we've managed to
It's not
tee
bad
up.
at all, is it?
The girls are also Skyping Dr. Carl in Sydney for scientific advice. And we've got our own professionals. We've got Dr. Windsor here that's helping us construct a Martian environment with CO2 levels and evacuated low air pressure, low temperature environments. The girls will be able to tell you about their simulation of growing plants on Mars for their next competition. There is nothing stopping our students from just pushing on at Chancellor.
That's sensational. That's sensational. Let's jump on to the next one. So we'll cut that and we'll jump on to the next one. Thanks, guys. Keep watching on facebook.com/Speech City Live.